Hello and welcome back to Calculus 3, the second part of the last lesson in chapter 14 on curvature and normal vectors. Last time we talked about curvature. We said that it quantifies how quickly the curve that we are observing turns, and we said that the formula for curvature was given as we divide the unit tangent, the magnitude of the unit tangent vector by the magnitude of velocity. Then we did few examples, show that the curvature of a straight line is 0, and we calculated curvature of a circle and then generalized that with the curvature for every circle, calling it 1 over radius. The goal for today is to discuss the principal unit normal vector, and this is going to be perpendicular to your tangent vector, and it could be very painful to compute. So if you have some kind of a curve r of t and you pick a point somewhere, you can get the tangent line at that point and then 90 degrees to it. There will be this normal vector n. If you pick a different point, let's say here, then your tangent vector would be this one, and the normal vector would be 90 degrees there. I hope you have a boat, not a car, because that type of a rain out there is not suitable for many vehicles. All right, so what is the definition and then the way to compute it? So let R denote smooth curve parametricized by arc length. The principal unit normal vector at the point P on the curve where curvature is different than 0 is n hat of s equals to the derivative of unit vector in terms of the arc length divided by the magnitude of the unit vector, the derivative of the unit vector, which can also be written as 1 over k dt ds but the formula that we want to use to calculate would be that the normal vector, and we look at it as the parameter of t when we do the same derivation as last time, we have dt over dt divided by the magnitude of the derivative So we recognize the form of a unit vector. Use this to compute normal vector. Now this can be really annoying very fast, because we need r, then we need r prime, then you need to compile t, then you need the derivative of t, right? So a lot of derivatives can get very nasty very fast. So let's compute one. Principal unit normal vector. Let's try problem 28. Looks good. R of t is given as 4 sine t, 4 cosine t, 10t. What is this? You should know by now. We used it in the last. Great. Helix. Wraps around which axis? X, Y, or Z? Z. Good. All right. So first we need R prime of t. That is going to be 4 cosine t, negative 4 sine t, and then 10. So now we have to find the magnitude of this so that we can compile the vector, the unit vector, tangent. So square root of 16 cosine squared t plus 16 sine squared t plus 100. When we factor out 16, sine squared plus cosine squared is 1, so we get square root of 116. Our unit vector t is going to be the vector we had 4 cosine t, negative 4 sine t, and 10 divided by square root of 116. Now, to find the normal vector, we have to differentiate t and then get that divided by the magnitude of t prime. So I'm differentiating now t, negative 4 sine t, negative 4 cosine t, and then 0 divided by square root of 116. And finally, I need the magnitude of t prime, which would be magnitude of this vector divided by 1 square root of 116. So I have a square root of 16 sine squared t plus 16 cosine squared t divided by 1/16 because the squares would kill the root in both terms. And no, this square root needs to do this, right? Because it's 4 divided by square root of 1/16. When I square it, it becomes 16 and the root dies, but it's still under big root. Okay, good. This is good. So now I have a square root of 16 divided by 1/16. Now we can cancel this and clean it up a little bit. So normal vector, and it's a unit vector because we are dividing by the magnitude, is going to be given by -4 sine t, -4 cosine t, 0, everything divided by square root of 1/16, and then over here I have a square root of 16 divided by square root of 1/16. Now square root of 16 is 4, and square root of 1/16 cancels, and then 4 cancels all of these, no coughing, so now it's equal to negative sine t, negative cosine t, and 0. There it is. So the normal unit normal vector is negative sine t, negative cosine t, and 0. This is what the normal vector calculation looks like when the problem is nice. Why is this problem nice? Because sine and cosine, right? That's why. Usually when you're integrating and differentiating, if you see e to the x, you should do a little celebratory dance because then it's easy, right? Well, when you see these types of calculations, when you see trig, you should do a little dance because they work out nicely. Let's do another one. So which one should we pick? These are problems over here, 29 in the corner, 29 through 34. Which one should we pick?
$31.
31. We just did the sine and cosine.
34. Oh, no.
34?
33.
33. 33. Look at 33. I mean, it's t squared and t. I mean, how bad this can be? Let's discover together. This is my trick question to all of the students, and pretty much every single Calculus 3 class, when I pose this question, which one should we pick, everyone goes, oh, 33 looks nice. I hear you. Let's go. R is given as t squared, comma t.
You gotta switch it back.
Yes.
Okay.
You're very welcome. That's how you properly address it. So now our R prime is 2t and 1. Simple. And now let's open the gates of hell. The magnitude of R is 4t squared minus 1. 4t squared plus 1. And you can't simplify that. You get to drag this through the entire problem. So this is why this problem is absolutely disgusting. But you picked it, so let's go. 2t, 1 divided by 4t squared plus 1. Now that is in our vector. Two t divided by square root of 4t squared plus 1, comma, 1 over square root of 4t squared plus 1. It's not that bad. But now we need t prime. So this is where the hell breaks loose. T prime is, and now we need to differentiate each one of these. And these are wonderful quotient rules with the chain rule in between. Now this is the way to do it. Ready? You select that term, you push the math button, and then you go t squared, fix it? Why? Is it? It's too close. Plus 1. You push the math button. It doesn't like it. Okay. 2t divided by square root of 4t squared plus 1. How about now? Do you like it now? There we go. And then you just say differentiate. So that's how you differentiate these things.
Use that on a test?
No, why would you? This is just a cool practice. And you swap this with 1, and you repeat the procedure. You select, you push math, you go here and say differentiate, and you get negative 4t divided by 4t squared plus 1 raised to the 3/2. Easy, not a problem at all. Now we need the magnitude of this. So that's the square root of 4 divided by 4t squared plus 1 cubed, because the square killed the half, plus 16t divided by 4t squared plus 1, again cubed because this killed. And we can factor out 4, which escapes the square root as a 2 in front, and we have the square root of 4, so that's 1 plus 4t divided by 4t squared plus 1 cubed. But isn't that the same? It's beautiful the way this simplifies, right? It's a good exam question. It's not. 2 divided by 4t. Oh wait, this one is the t squared. No, it doesn't cancel. It doesn't cancel because this one is a t squared, and this one is just t. So nothing cancels there. Yeah, this is the end. So I don't need this. That's the end because they don't cancel. Now the normal vector, principal unit normal vector, and hat of t is when we divide these two. So we have our vector of 2 divided by 4t squared plus 1 3/2, comma, negative 4t divided by 4t squared plus 1 raised to the 3/2, divided by 2 square root of 1 plus 4t divided by 4t squared plus 1, and that's cubed. Well, great. We have stuff that we can cancel and combine. For instance, the 2 and the 4 cancel with the 2. You get a 2, you get a 1 over here. So normal unit vector is going to be given by, now I have, if you just call the whole mess y, you have y to the 3/2 divided by y cubed. No, it's the other way around. So when you subtract these powers, 3 minus 3/2, you're going to get 3/2. So this is going to be what? 1 divided by 4 this and this cancels, so this goes in the numerator. So I have 4t squared plus 1 to 3/2 divided by 1 plus 4t. There we go. 1 plus 4t. Perfect. And the second term is negative 2 times 4t squared plus 1 to the 3/2 divided by 1 plus 4t. Simple, no, not an issue. Now, if I provide that t is equal to 3, you plug that in and you come up with a number, right, the vector. Out of all of the problems that you've seen over there, so all of the problems you see, 29 through 34, 34 is the cheapest one of all of them. It simplifies nicely. 34. The rest can be tricky. So 34 is the nicest one. Good. So that's the way to find a normal vector. Now, why? Why do we bother going through all of these calculations? Well, it turns out that if you want to measure acceleration, there are tangential and normal components of acceleration. And for that, you need the normal vector and the tangent vector, unit vectors. So, application, we're not going to go to this because this is applied physics. But application is that acceleration vector is the normal component an times the normal vector n of t plus the tangential component AT times the unit vector T to give it. And this is not in I and J component, IJK, because these components, right, acceleration can go in any direction, not just IJK. So this is where we would use it, the entire calculation, and then, you know, since this is the answer, that would plug in here when you're doing your physics, and it would go from there. If you're interested in these things, you can calculate. And that's it. I hope you're not disappointed. Bye.